In this video, I'm going to show you how to solve linear equations and rational equations. So let's go ahead and get started. It says a linear equation in one variable, in this case x, can be written in the form ax plus b equals 0, where a and b are real numbers and a is not 0. So in other words, a linear equation will have a variable such as x to the first power. Remember, x, written as it is, indicates that the exponent is to the first power. So all these equations are linear equations. Now, if you watch some of my previous videos, I showed you how to solve linear equations using the CSI 1 and 2 step. So if you're not real strong at solving equations, you may want to watch those before you watch this video. Alright, so look at number 1. Our goal when we solve linear equations is to get x by itself. And in this problem, to get rid of the minus 12 there, we're going to want to add 12 to each side. And that's going to leave us with x on the left. On the right side, we're going to get 8. And so our solution is x equals 8. This is what I call a one-step equation because I only needed to do something to each side once to solve this equation. If you look at number 2, that's what I would refer to as a two-step equation. In order to get x by itself, I'm going to need to get rid of the 3. Since it's 3 times x, I'll have to divide each side by 3. And to get rid of the minus 8, I'm going to have to add 8 to both sides. With two-step equations, we learn that you always add or subtract first. So in this problem, let's go ahead and add 8 to each side. We're going to get 3x on the left and 15 on the right. And then you can see that x is going to be 5. Now, number 3, it's a little bit different. This is one of those equations where you have x on both sides. Notice there's nothing I could simplify on either side. For example, on the left, excuse me, the 4x and 7 are not like terms, so you can't combine them. Same type of things going on the right side. So in this case, the only thing I can do at this point, or the thing that I'd want to do, is get x on one side only. So let's go ahead and add 2x to both sides to get rid of the minus 2x on the right. We're going to get 6x plus 7 equals 8. Notice this is a two-step equation, so we'll subtract 7 on both sides. And then we're going to need to divide each side by 6. Again, I want to get x by itself. The opposite of multiplying by 6 is dividing by 6. So we're going to get x is equal to 1/6. Now on number 4, notice what we're going to do first is simplify. And so we have 2 times x, which is 2x. 2 times the minus 1 gives you a minus 2. We'll bring down the 3. On the other side, let's write the x, and then you're going to have to distribute the minus 3. You'll get minus 3x. And a negative 3 times 1, you're going to get minus 3. So I want to actually talk about the CSI 1 and 2 step with this problem. Notice in this problem, we don't have any fractions to clear. That's what the C means, clear fractions. So we don't have to worry about that. S means simplify. And so we want to simplify on each side as much as we can. And in fact, in this problem, distributing is just the first step. We have a little more work we can do to simplify it. Notice the minus 2 and the 3 are like terms, so we're going to get 2x plus 1 on the left. On the right, we have an x and a minus 3x. And that's negative 2x. And then go ahead and bring that minus 3 down. So I need to get, well, first of all, I've simplified everything that I could. So now the I is for isolate. If I have x on both sides, I need to get rid of it on one of the sides. So we can do that by adding 2x to both sides. We get 4x plus 1 equals negative 3. Again, this is a two-step equation. And hopefully by the point by this point you're home free because it's going to take us 2 more steps. We'll subtract 1 on both sides, and we get 4x equals -4, and we'll divide by 4 on both sides, or you can just do that in your head. All right, let's move on. These are actually 2 special cases. Weird things happen with these. We're going to solve them just like the others. So let's simplify. Notice on number 5 we need to simplify on the left. We can distribute. We get 4x plus 20. We'll rewrite the right side. So we've simplified everything that can be simplified. Let's go ahead and we need to get x on one side only, so let's subtract 4x on both sides. Notice when you do that, though, you lose x on each side, and what you're left with is 20 equals 21, which is a false statement. And so that's false. This indicates that there is no solution. And the other way we can write that is using the empty set notation. So either way is correct. I wrote both here. On number 6, we're going to again simplify everything that we can. We've got some distributing to do. Distribute the -1 there, you get a -2x and a +7. On the other side, you got to distribute that 7 and bring down the -3x. We still have some like terms. We're going to get 4x plus 7 on the left. On the right, we have the 7x and the -3x, which is 4x. We're left with 4x plus 7. So this is interesting. We have 4x plus 7 is equal to 4x plus 7. Well, that's going to be true no matter what x is. Now, if you didn't notice that, this is actually called an identity because it's always true no matter what the variable is. I can plug in any number and it'll be true. But we could actually subtract 4x on both sides and then subtract 7 on both sides and get it all the way down to 0 equals 0. In any case, our answer is all real numbers. So that's how you can write it in words, or we have a symbol that we sometimes use. It's like a 2-legged capital R. And basically, the real numbers are all the numbers that we can represent on a number line. So fractions, decimals, integers, whole numbers, radicals, pi, pretty much anything you would think of except for if you learned about complex numbers that have an I in them. Everything else is real. And that's what we're working with most of the time when we're solving equations. Let's move on. So it says a rational equation is an equation containing one or more rational expressions, also known as fractions. So our steps are to list any restrictions. We'll talk about that when we get to the next page. Find the LCD of the denominators. Clear fractions by multiplying each side of the equation by the LCD. That's the key step here. Basically what we're doing there is we're making fractions disappear, which I think most people would like to do. So by multiplying by the LCD on each side of a rational equation, we should eliminate all the fractions. Then we solve the resulting equation, and the last thing to consider is if you get an answer and it's a restricted value, you need to throw it out. So again, we'll get into restricted values on the next page. Let's go ahead and look at number 1. We don't have any restrictions for 1 and 2 because we don't have any x's in the denominator. The LCD for 5 and 6, you may recall, is 30. Now, how did I get that? Well, an LCD is really an LCM, or least common multiple. So I look at the multiples of 5 and the multiples of 6 until I find one that they have in common. The first one they have in common is the least common multiple. So in this case, that would be 30. So we're going to multiply each side of this equation by 30. So basically I'm going to do this. Now I got to multiply the whole side by 30, so on the right I'm going to have to distribute. So basically what happens is each term on both sides of the equation gets multiplied by the LCD. I'm not actually going to write it this way. So let me erase what I just put there. This is how I'm going to write it. So I'm going to multiply each term by my LCD. Now notice 30 times x over 5, the 30 cancels with the 5. 30 divided 5, or 30 over 5, is 6, and we're left with 6x. On the other side, 30 divided 6 is 5, and I'll be left with 5 times x, or 5x. And don't forget, you also have to multiply the 30 times the 1, even though it's not a fraction. We multiply each term by 30. And now notice we cleared fractions, and so at this point we need to get x on one side only, and we're going to get x equals 30. Alright, let's look at number 2. Our LCD here is going to be 10. Now you could write all the multiples of 5, 2, and 10 out and find the smallest they have in common. The shortcut I would use, or that I do use, is I look at the biggest denominator, in this case 10, and I'm going to look at its multiples. Now notice 10 is divisible by the 2 and the 5, the other two denominators. And so I look for the first number that's a multiple of the biggest number. I look at the multiples of the largest number until I find one that I can divide by the other denominators. And in this case, 10 is a multiple of 5 and 2, and so that is going to be my LCD. So let's go ahead and multiply each of the terms by 10. Now I want to show you another way you can do this. It's a little bit longer. I could write that 10 as 10 over 1. And let me do the work down below a little bit. If we multiply across, we get 10x over 5. And that reduces to 2x. So that's kind of the long way to do it. You're going to see, and you've already seen, that I'm going to do it where we cancel. It makes things a little bit easier. So notice we have 10 times x over 5. 10 over 5 is 2. And we're left with 2x. Don't forget to put the minus in there. And then 10 times x over 2. 10 over 2 is 5, and we're left with 5x. On the other side, 3 times 10 is 30. On 10 times 3x over 10, the 10's cancel, and you're left with 3x. So again, we've cleared fractions. Now we have some like terms on the left that we can combine. So this is part of simplifying. On the right side, there's nothing we can do, and now we need to get x on one side only. So we'll subtract 3x on both sides. We're going to get negative 6x equals 30, which means x equals negative 5. All right, let's move on to the next page. So number 3 is similar to the one we just did, but just a little bit different. Let's go ahead and find our LCD. So again, you should start looking at multiples of 5. And if you keep going, it takes a while before you find one that's divisible by 2 and 3. It's going to be 30. And so that is my LCD. I'm going to multiply everything by 30. Whoops, let's see, LCD equals 30. And so let's see, 30 over 5, that's going to be 6. Times the 3x that's left, we get 18x. Minus, let's see, 30 over 2 is 15. Now notice I'm going to multiply the 15 times the whole numerator there, which is x minus 3. It's a binomial. I'm going to have to distribute. I would do this in 2 steps, even though you can do it in 1. We're going to have minus 15 times x minus 3. On the other side, 30 over 3 is 10, and we're going to distribute the 10 times the x plus 2, which is in the numerator there. And so now if you think back to the CSI technique, we just cleared fractions, and now we're working on simplifying. So we have some distributing we can do. Let's see, we can distribute on the right side as well. And notice we do have some x terms we can combine on the left. That's still part of simplifying. So we get 3x plus 45 equals 10x plus 20. So we've done all the simplifying. And let's see, we need to have x on one side only, and we don't. So we're going to want to subtract 10x on both sides. Notice you could subtract 3x on both sides, and that'll also work. I'm going to keep my x on the left. And I end up with negative 7x plus 45 equals 20. So as I've said before, with the CSI 1 and 2 step, if you do the C, S, and the I, then you always end up with a 1 or 2 step equation. Here we have a 2-step equation. Subtract 45. We're going to get negative 7x equals negative 25. Divide by negative 7. Now we have a negative divided by negative, which is a positive. We can write this as 25/7. All right, so on number 4, now we have a variable in the denominator, and so things are going to be a little bit different. So first of all, our LCD will include the number 6, which is the LCD of 3 and 2. But the thing about it is, if I just multiply by 6 here, notice the 6 will cancel with the 2, but it won't cancel the x out. So I'm going to need to include any algebraic factor that I don't already, or any algebraic factor that shows up in the denominator. So I do need to include the x here. So my LCD is 6x. And the other thing I want to point out here is if x is 0, then 2 times 0 would be 0. And my denominator being 0 would make me undefined. So x could never be 0. That's my restricted value. A restricted value is just a value of x that would cause the denominator to be 0, which would make the expression undefined. So our restricted value is x cannot be 0, or it is 0. So let's go ahead and multiply all our terms by our LCD. Let's see, the 6 and 2, we're going to get 3 out of that. X's cancel, we're left with 3 times 7, which is 21. Let's bring that minus down. Let's see, we got a 6 over 3, which is 2, and the x's again will cancel. We're left with a minus 2 times 5, which is 10. On the other side, 6 over 3 is 2, and we're left with 2 times x times 22. We're going to get 44x. Be careful when you're clearing fractions. It's very important that if your term should have an x or not, it's got to be done correctly or it's going to throw things off. So be careful. In this situation on the right here, you've got to make sure you don't forget about that x. On the other side, in both cases, the x canceled. So let's see, we've cleared fractions. We've got some simplifying we can do on the left. We're going to have 11 equals 44x. Now be careful, if you rush here, you might think x is 4. But to get x by itself, you actually need to divide by 44. This actually reduces to 1/4. Now notice I didn't get 0. If I had gotten an answer of 0, I'd have to throw it out, because we already said x can't be 0. It makes the equation undefined, or the expression in the equation undefined. So 1/4 is a okay solution. Let's move on to number 5. Now first of all, in this problem we only have an algebraic factor, which would be x plus 4. X plus 4 is just 4 bigger than whatever x is. We don't have a product here, and so we have to treat the x plus 4 as a single factor. So that is my LCD. and I've got it twice. And notice that if x were negative 4, our denominator for both fractions would be 0 and we'd be undefined. So our restricted value here is x cannot be negative 4. So let's multiply each of the terms by x plus 4. Notice with the first fraction here, when we multiply, the x plus 4's cancel, which means we're left with 3. And then we're going to have minus 7 times x plus 4. So I'm just going to go ahead and write that out. I'm not going to distribute yet. And on the right side, again, x plus 4 is going to cancel, and you're left with negative 4. So when we clear fractions, this is what we end up with. We've got some simplifying to do. We need to distribute. And then we have some like terms, the 3 and the minus 28. So we're going to get negative 25 minus 7x. On the other side, negative 4. So again, we've done the CSI steps, and we have a two-step equation. So we always add or subtract first. We'll want to add 25 to both sides. We're going to get negative 7x equals 21, which means x is negative 3. Now before I box my answer, notice that x can't be negative 4, and we didn't get negative 4, so our solution is a good solution, and we're done with that one. All right, one more to go. I want you to notice x squared minus 4 is a difference of squares. If you are rusty on your factoring, it's very important that you do the factoring assignment. It's something that if we haven't already done, we'll do it probably in the next class, or at least work on it. But it's important that you know how to factor. X squared minus 4, difference of squares factors is x minus 2 times x plus 2. So this is very similar to number 5, except this time we have two algebraic factors, and again we have no other factors. And so our LCD will include both of these algebraic factors, x minus 2 and x plus 2. Our restricted values are going to be 2, because 3 over 2 minus 2, that'd be 3 over 0, that would be undefined. And notice 1 over x plus 2, if x was negative 2, then we'd have the same problem. So these are our two restricted values. Let's go ahead and clear fractions now. So when you multiply x minus 2 times x plus 2 times the first fraction there, notice the x minus 2's are going to cancel, and you're left with 3 times x plus 2. When you multiply x minus 2 times x plus 2 times the second fraction there, the x plus 2's are going to cancel, and it's going to leave us with 1 times x minus 2. And then on the other side, notice the x minus 2 and x plus 2 are both going to cancel, and we're left with 12. All right, so we've cleared fractions. We've got some simplifying to do. We got to distribute, combine our common or like terms. We get 3x and x is 4x. 6 and a minus 2 is 4. Notice we now have a two-step equation, so we can subtract 4 on both sides, and we're going to get x equals 2. But again, just like with number 5, we want to make sure that we check to see that we didn't get a restricted value, and here we did. So we got x equals 2, but we know if we plug it in, it makes us undefined, and so we have to throw that solution out. There are no other solutions, and so our answer is no solution. Again, there's two ways to write that, and that's the end of this lesson.